Hello everyone, welcome to my channel Mathenthusiasm. Today we're going to solve this exciting problem. If the sum of sines and sum of cosines are both equal to 1 over 2, find the sum of tangents. First of all, let's eliminate the unknown y. By how we can make sine y and cosine y as the subjects of the two equations. Let's call them equations 1 and 2. Take the square of the two equations, then we add them up like this. The reason is that we can use square identity on the left-hand side. Sine squared y plus cosine squared y is equal to 1. For the right-hand side, both of them are perfect square a minus b whole square, which is a squared minus 2ab plus b squared. So expanding the first bracket, we have 1 over 4 minus sine x plus sine squared x. For the second bracket, we replace sine x by cosine x. Now, we add up the two constants 1 over 4 to get 1 over 2. Then we use the square identity again on the right-hand side to get another constant 1. Rearranging the terms, we have an important relation. Sine x plus cosine x is equal to 1 over 2. Let's call this equation 3. So how do we move on? Let's square both sides of equation 3. The left-hand side is a perfect square of the form a plus b whole square. Expanded, we have sine squared x plus 2 sine x cosine x plus cosine squared x. Using the square identity for the third time, then the equation is 2 sine x cosine x plus 1 is equal to 1 over 4. Now, we get the value of the product sine x times cosine x, which is negative 3 over 8. Let's call this equation 4. So, what can we do with the sum and the product? Yes, we can form a quadratic equation with two roots sine x and cosine x. We use the unknown u for the equation. Then it is u squared minus 1 over 2u minus 3 over 8 is equal to 0. Multiply the whole equation by 8 so that all the coefficients are integers. We're going to solve this to find the values of sine x and cosine x. Although this equation cannot be factorized, we can use the quadratic formula to solve it. Let's put a equals to 8, b equals to negative 4, and c equals to negative 3. So u is equal to 4 plus or minus the square root of 112 over 16. Simplify the third, square root of 112 is equal to 4 times the square root of 7. So the simplest form of the answers is 1 plus or minus square root of 7 over 4. Note that these two values are sine x and cosine x, so we have two possible cases. Moreover, we use the original equations from the very beginning to get the values of sine y and cosine y as well. You can see that the values of the pair sine x, cosine x, and the values of the pair sine y and cosine y are reversed. It is also the case for another set of answers. Now everything is ready. We can find the value of the sum of tangents. Let's write tangent x as sine x over cosine x, and the same for tangent y. For the first set of solution, it is 1 plus square root of 7 over 1 minus square root of 7 plus 1 minus square root of 7 over 1 plus square root of 7. We also put the second set of solutions into it. Can you see that the two fractions are exactly the same? They give the same value of tangent x plus tangent y. Great! We just have to handle one case. Now, let's look at the numerator and the denominator of the two fractions. They are the conjugate pairs. So it's really easy to simplify. Let's check it out. Combine the two fractions, we'll have two perfect squares in the numerator. 1 plus square root of 7 whole square plus 1 minus square root of 7 whole square. For the denominator, it is of the form a minus b times a plus b, which is a squared minus b squared. The common denominator is 1 minus 7. So the expression is rationalized. expand the two brackets by the identities again. Now, we can see that the two sides cancel out. So the answer is negative 16 over 6, which is equal to negative 8 over 3. This value is really nice. Can you see why? It is exactly the reciprocal of the product sine x times cosine x. So what is the reason behind? I shall leave this bonus part for you. You may watch the last minute of the video again to get the idea. If you want to know more interesting questions of trigonometry, please check out the links of the videos and the playlist on the screen and the descriptions below. See you in next video.